This presentation will be delivered through Prezi. The Algebra 1 units for ninth grade are listed below. Today's lesson is going to focus on factoring, which is actually Unit 7B. We're going to click on Unit 7B. These are the standards associated with factoring. Given the situations, what utilizes formulas or expressions with multiple terms and or factors, interpret the meaning and context of the individual terms or factors. Use the structure of an expression to rewrite it in different equivalent forms. So for today, we are going to focus only on one certain factoring technique, which is called difference of squares. The learning objective for this lesson will be to learn how to identify a special case for binomials and how to factor it. The special case which we will discuss is called difference of two squares. A polynomial is a difference of two squares if these two situations apply. There are two terms, both of which are perfect squares, which a perfect square, an example could be like 25. When you take the square root of a perfect square, the same number times itself will give you that value. So the square root of 25 is 5 times 5. The square root of 36 is 6 times 6. There's a minus sign also between the two terms. That's the second case that needs to happen. So if there's a plus sign in between, it's not a difference of two squares. The rule for factoring a difference of two squares is a squared minus b squared is equal to a plus b times a minus b. So for our first example, we're going to notice that we have an x squared minus 64. X squared is a perfect square because when you do x times x, that is x squared, so you can take the square root of it. This 64 is a perfect square. When you take the square root of 64, it is 8 times 8. So that is why once you identify those are perfect squares and there's a minus sign between them, you have an x, 8, 8, and one has a minus and one has a plus. So that's how you would rewrite it, and this is fully factored. Now, let's go back and look at a different one. Let's look here. This example, 9x to the fourth minus 25. 9x to the fourth is actually a perfect square because if you do 3x squared times 3x squared, you get 9x to the fourth. So this is where we get the 3x squared here. And then the 25 is a perfect square because when we take the square root of 25, you have 5 and 5, and then you have a minus and a plus. That minus and plus will always happen every single time. That's just a part of the formula and how you factor it. Let's look at one more example here. This is an example where we're actually prime because a squared is a perfect square, 16 is a perfect square, but there's a plus sign between them, not a minus sign, so it's not a difference of two squares. All right, so there's no GCF you can factor out, and it's not a difference of squares, so we call it prime. It is not factorable. All right, so those are some examples of how to factor difference of two squares. That is our lesson for today. Thank you.